Today we're going to talk about solving and graphing two-step inequalities. So I hope you remember from a couple lessons ago, we talked about solving two-step equations. And if you remember, it's adding and subtracting first, and then it's multiplying and dividing second. So we got rid of the positive 2 first and moved it over, and then we got rid of the multiplied by 4 divided or negative 4 and moved that over by doing the inverse operation. So we're doing the exact same thing here to solve it, but we're also adding in those rules that we learned for the greater than or less than or equal to symbols that we use for inequalities. So after we answer the problem, and don't forget that important note, that if we are dividing or multiplying by a negative, then the symbol changes, okay? So let's go ahead and practice these. It says two-step inequalities are solved just like two-step equations. The only difference is that there is an inequality sign. Solve them the same way, but don't forget to think about what the inequality means. Recap, how do I get rid of a fraction? Does anyone remember, how do you get rid of a fraction? I hope you were thinking in your mind that you use the reciprocal. Reciprocal is when you flip it and multiply, okay? So let's go ahead and do some of these examples. 4x minus 1 is greater than or equal to negative 17. The first thing that I need to do is add or subtract. The only part that I can add or subtract is minus 1. This is 4 times x. That would mean I'd be dividing, which is the inverse operation. Here, subtracting 1, the inverse operation is adding 1. And remember, whatever you do to one side of the inequality, you must do to the other side. Here's your symbol to help you understand which side is which. A negative 1 plus a 1 brings us to 0. So all that's left on this side is 4x is greater than or less than, and negative 17 plus 1. Well, if I'm at negative 17 and I add 1, I'm going to go right on the number line, which means I'm going to get bigger, but the 17 turns into a 16, because remember, on the negative side, the closer you get to 0, the bigger the number is. So this one is negative 16. Now, I'm not finished yet, because there's still a coefficient touching my variable. I want to get rid of this 4. Well, if it's 4 times x, I'm going to do the opposite, which is dividing by 4. Remember, you don't want to divide by 4x because that would move the x to the other side. 4 divided by 4 is a positive 1, so all that's left is 1x is greater than or equal to, I keep the sign the same because I'm not dividing or multiplying by a negative. And then this side, negative 16 divided by a positive 4. Well, a negative and a positive means it's going to be negative. And 16 divided by 4, how many times can I count by 4 to get 16? 4, 8, 12, 16. 4 times. So my answer is negative 4. So I'm going to go ahead and put my dot at negative 4. Now it's going to be closed because it has the equal to sign. That means it could also, the answer could be negative 4. Now it says x has to be greater than or equal to negative 4. Well, greater than means I go to the right on the number line. So I'm going to make my line go that way, and don't forget to put your arrow, because remember, it could be all the way over here on the number line. So is let's say this is 6 is where our number line stops. Let's say we were over here at 25. Is 25 greater than or equal to negative 4? Yep, 25 is definitely greater than negative 4. Let's try number 2. 5, so a positive 5 minus 9x is less than negative 13. So they're trying to trick you a little bit here. They changed the order. Where do you see that we could add or subtract first? Well, we could take this positive 5 and move it over, because this is a negative 9 times an x. So we can't do that one yet. We have to get rid of the 5. What's the opposite of positive 5? Well, negative 5. So I'm going to do a minus 5 on both sides, because 5 minus 5 is 0, so that's gone. All that's left is the negative 9x is less than, and what's negative 13 minus 5? Well, we keep the sign negative and we add them together. So negative 18. Okay, now the second step is to get that coefficient away from our variable. So if it's multiplying by negative 9, we're gonna divide by negative 9. Since I'm dividing by a negative 9, my symbol is gonna change from less than to greater than. Negative 9 divided by negative 9. Well, a negative divided by a negative is a positive, and 9 divided by 9 is 1. So we now have just a positive 1x left on this side. A negative divided by a negative is positive. 18 divided by 9. Well, if I count by 9s, 9, 18, 2. So my answer is a positive 2. So x is greater than 2. So let me find the 2 on the number line. And I'm not going to close it because there's no equal to. That means my answer cannot be 2. Is 2 greater than 2? No, 2's equal to 2. So we're going to leave it open. So now x has to be greater than 2. Greater than means I go to the right on my number line and draw my arrow. Let's look at number 3 and try that one. 8. Oh, look at here. They're tricking us a little bit. They're putting the it's not really the answer, but it's like this side's already done and this side has the x now. So it's the same thing. We're still moving things away from the x. So all of these numbers need to come way over here with the 8. So let's see how we're going to do that. 8 is greater than negative 12 plus 5x. Well, I already know I can't do this one first because it's multiplying and I need to add or subtract. So the negative 12, how would I get to 0 from negative 12? Well, I would add 12. That would bring me to 0. So I'm also going to add 12 on the other side. Negative 12 plus 12 is 0. So I'm going to just bring down what's left. A positive 5x, bring down my symbol, and 8 plus 12 is 20. Now, we still have a coefficient touching the x. The 5 is touching the x. That means multiplying. We need to do the inverse operation. So we are going to divide by the 5, and it's a positive 5. Because I'm dividing by a positive, my symbol's going to stay the same. 5 divided by 5 is 1, so good. I just have one x on that side. 20 divided by 5, 5, 10, 15, 20, 4. So my answer is 4 is greater than x. Let's go ahead and graph that. 4 is greater than x. So I'm going to put a circle at 4. I'm going to leave it open because it's not equal to. Is 4 greater than 4? No, it sure is not. So now 4 is greater than x. That means that x has to be smaller than 4. So I know I need to go toward the negative side and put my arrow to show it's going to keep going. Before we end this lesson though, I want to make sure that you understand how we could flip these to make them look a different way. So if I wanted to have the x on this side, look at how this is. So let's read it backwards. X is less than. How do I know it says less than, that I should be putting less than there? X is less than 4. Because I've switched the x to the other side, and look at that, the alligator mouth is eating the 4. So if I switch it to put x on this side, if it's easier for me to read this way, I need to make sure the alligator mouth is still eating the 4, showing that x is smaller than 4. How would we do this one if we wanted to put x on the other side? Well, remember, so the alligator mouth, our inequality symbol, is eating the x, so it still needs to do that. So if I put the 2, I want still to be eating the x. So now it reads as 2 is less than x, or x is greater than 2. They are saying the exact same thing, just like these two are. So keep that in mind, that you might see that sometimes, and you need to be able to understand how to flip them. So if if 4 is greater down here, 4 still needs to be greater here. And how do we know that? Because the alligator mouth is eating that 4 still. And so let's read this how it would be read as an inequality. 4 is greater than x, And this means the same thing. We're just going to say it differently. X is less than 4. Okay, so both of those mean the same thing. Let's look at our practice and make sure there are no surprises. So you should be okay with number 1. You should be good with number 2. And you should be good with number 3. All right, so good luck.